Hello everyone. In today's lecture, we'll be discussing about the first law of thermodynamics. First, let us see the basic definition of first law of thermodynamics. First law states that when closed system undergoes a cyclic process, the net heat transfer is equal to net work transfer. That means heat can be completely converted into work or work can be completely converted into heat during a cyclic process. Now what is this cyclic process? For example, if there is a process which is changing from state 1 to state 2 and again from state 2 it is coming back to state 1. This is called as cyclic process. That means a process which is repeating from 1 to 2 and again 2 to 1 is a cyclic process. So in this cyclic process, it takes two processes to complete the cycle. So this is what the first law states. During a cyclic process, heat added can be completely converted into work or work can be completely converted into equal amount of heat. So mathematically we can write it as this represents the cyclic integral. So cyclic integral of del Q is equal to cyclic integral of del W. So this is how mathematically we write the first law of thermodynamics. The first law again states that it is based on the law of conservation of energy. That is why heat can be converted into work or work can be converted into heat. Now what is this conservation of energy? According to the conservation of energy, energy can neither be created nor destroyed. It can be only converted from one form of energy to another form of energy. Now let us understand this with an example. Now for example, if I pick a stone from ground, now the stone will have some mass m and when it is on the ground it is having some internal energy. Now when I throw this stone upwards, what will happen? This internal energy will be converted into kinetic energy and it will go and stop at some point and then it will come back again due to gravity. As we know, any object if we throw in the air, it will come back on the ground. So what is happening? The internal energy which was present in the stone will be converted into kinetic energy and when this stone stops at a point, this kinetic energy will be converted into potential energy and again when it is falling down, this potential energy will be again converted into kinetic energy and when this come and fall on the ground, again some energy will be given to the contact surface, isn't it? So we say that energy can neither be created nor destroyed. It is only converted from one form of energy to the another form of energy. Now let us understand the law of conservation of energy with another example, and here we are considering heat. Heat is denoted by Q. Now as we know, heat is also a form of energy. So heat can also neither be created nor destroyed. Only we can convert it into another form. So in first law of thermodynamics, we are trying to convert heat to work. Now for example, here we are considering a piston cylinder arrangement. Now this cylinder is containing some gas and when we apply heat to it, the molecules of the gas expands and tends to move the piston upwards. So as we apply heat, the piston will be moved upward. That means heat energy is converted into work. This process we can see in IC engine also. In SI and CI engine, we undergo combustion because of which the piston moves and we get mechanical work output. So there are so many applications of this first law of thermodynamics. So remember, this gas, it was already having some internal energy and when heat was applied to it, there was change in internal energy which in turn gave work output. So mathematically we can write it as dE is equal to delta Q minus delta W. this is change in internal energy inside the cylinder will be equal to heat supplied minus work what we have got. Okay, that means this much amount of internal energy has to be changed. Now what does this D and delta means? D means exact differentiation and delta means inexact differentiation. This topic we have already covered while discussing the point function and path functions. So internal energy is considered to be the point function. So we consider it to be the exact differentiation, whereas heat and work are the path functions. So they are inexact differentiation. So here energy is extensive property. Extensive means it depends on the quantity of mass. Energy which we can find here is the kinetic energy, potential energy and the internal energy. So this you can see here, this is the kinetic energy, potential energy and the internal energy which is present inside this system. So now summation of this will give you the total energy. Now as we know, this in the differential form we can write it as integral from 1 to 2 dE is equal to integral from 1 to 2 delta Q minus integral 1 to 2 delta W. Note that there is no change in potential energy of the system when datum level is same. And since there is no potential energy, we consider that we are neglecting the potential energy and we say that PE1 will be equal to PE2. So since we are neglecting the potential energy, we say that this will be equal to 0. Similarly, there is no flow of mass in or out of the system, and because of this the kinetic energy will be also equal or negligible, and this term also we will consider it to be 0. So on simplifying this, only the internal energy will be remaining. So this equation can be also written as del Q is equal to Q minus W. So this is the simplified form of the first law of thermodynamics, which says that the internal change in internal energy will be equal to heat supplied minus work done. So hope you understood the first law of thermodynamics. Thank you for watching the video.